Have you ever wondered why we feel so comfortably wrapped in the boundaries of our small world, while an infinite expanse stretches out just beyond our atmosphere, holding structures so large they challenge the very limits of human imagination? It is a gentle paradox of our existence that we walk our familiar streets, feeling the solid ground beneath our feet, completely oblivious to the vast and silent theater operating in the deep night sky above us. But the cosmos measures itself in eons and light years, in gulfs of emptiness so profound that our minds simply cannot hold them. I invite you to leave the noise of the day behind, to take a quiet breath, and to join me on a journey into that endless dark. Let us venture out together into the ancient mystery of space, where the true scale of the universe awaits us with a gentle, imposing wonder. To truly understand the biggest things out there, we must first look at our own home, the Milky Way galaxy, which scientists classify as a barred spiral galaxy. It is a beautiful, swirling structure with gracefully curving arms made of ancient stars, cool gas, and shimmering dust, all slowly rotating around a brilliant central bulge where a supermassive black hole sits in silence. From one outer edge to the exact opposite side, our galactic home measures roughly 100,000 light-years across. That means if you could somehow travel at the absolute speed limit of the universe, the speed of light, it would still take you 100,000 years just to cross from one side of our galaxy to the other. That length of time is already almost impossible to truly grasp. 100,000 years is a span far longer than modern humans have existed upon the earth. It is longer than the time that has passed since we first learned to press our hands against cave walls and paint our stories in ochre. It is longer than every human civilization that has ever risen, flourished, and fallen combined. And yet, that immense span is just the physical width of our own little corner of the cosmos. Within this vast pinwheel of light, the Milky Way provides a home to somewhere between 200 billion and 400 billion individual stars. Each one of those countless stars is a glowing nuclear furnace, and many might have their own families of planets orbiting around them, moons circling those distant worlds, ancient asteroids tumbling aimlessly through the dark, and comets streaking through the absolute void. Our sun is just one single star among those hundreds of billions, resting quietly about 26,000 light-years from the dense galactic center in a relatively peaceful and quiet neighborhood known to astronomers as the Orion Arm. Our sun, carrying its fragile family of planets along with it, orbits the center of the galaxy at an astonishing speed of about 500,000 miles per hour. Even while moving at that tremendous, incomprehensible velocity, it still takes our solar system about 250 million years to complete a single, sweeping lap around the galactic center. Astronomers sometimes refer to this immense period of time as a cosmic year or a galactic year. To put that gentle rhythm into perspective, in the entire time that the great dinosaurs roamed across the surface of the Earth, our solar system did not even manage to complete one full orbit around the galaxy. The very last time our sun was passing through roughly this same position in the Milky Way, the most complex forms of life swimming on Earth were simple marine organisms. That is how unimaginably vast even our own familiar galaxy is. Yet, despite containing billions of shining stars, the space between those stars in the Milky Way is almost entirely and unimaginably empty. Our nearest stellar neighbor is a small, quiet red dwarf star called Proxima Centauri, and it is located about 4.24 light-years away from us. That distance is so great, so profoundly deep, that if you could somehow magically shrink our massive sun down to the tiny size of a single grain of sand, Proxima Centauri would be just another microscopic grain of sand sitting quietly about 4 miles away. The vast space in between those two tiny grains would be essentially a complete void, carrying only the faintest whisper of thin gas and microscopic dust, alongside the occasional invisible particle of cosmic radiation. This deep, quiet emptiness is very hard for our earthly minds to wrap themselves around. We live our entire lives on a crowded, vibrant planet, constantly surrounded by billions of other people, sharing our living space with countless other breathing, moving things. But the moment you step outside the boundaries of our solar system, total emptiness becomes the fundamental rule of reality. Stars are separated by such vast, unbridgeable gulfs that the mathematical chance of any two of them colliding by pure accident is essentially zero. Entire galaxies can pass right through each other like ghosts without any of their individual stars ever actually hitting one another. Yet somehow, even in all that endless, sprawling emptiness, there is enough material out there to forge hundreds of billions of stars in our galaxy alone. The primordial gas and cosmic dust floating between the stars may seem sparse, but when it is spread across thousands upon thousands of light years, it adds up to truly enormous amounts of creative material. Beautiful new stars are forming right now in giant molecular clouds, scattered like cotton throughout the Milky Way, gentle places where gravity has patiently pulled enough gas together for nuclear fusion to finally ignite. Our galaxy is alive with the gentle spark of stellar birth, even as ancient stars slowly burn out and fade into the deep night. When you step outside and look up at the night sky from a perfectly dark location, free from the harsh glare of city lights, you might see a hazy, beautiful band of light stretching directly overhead. That soft glow is actually the combined light of billions upon billions of distant stars residing within our own galaxy. Ancient, curious people looking up at that exact same sky thought it looked like a trail of spilled milk washed across the heavens, which is precisely where the gentle name Milky Way originally comes from. For almost the entirety of human history, we looked up and simply assumed that this glowing band was everything that existed. We honestly thought our solitary galaxy was the entire, complete universe. Different cultures around the world created beautifully different explanations for that mysterious band of light. The ancient Greeks told grand stories of milk spilled from the goddess Hera's breast. Aboriginal Australians looked up and saw it as a majestic flowing river in the sky. People throughout all of recorded history have looked up at that very same band of soft light and felt a deep, resonant wonder about what it might truly be. The biggest galaxy we have ever discovered is so unimaginably large that your brain will genuinely struggle to truly understand its proportions. This statement is not an exaggeration, nor is it dramatic storytelling. This is the pure, honest truth about a silent, cosmic monster that sits in the dark over 1 billion light years away from us. It exists quietly in the deep darkness of space, patiently holding more stars than you could ever possibly count in 1,000,000 human lifetimes. If you're anything like me, you probably grew up thinking you understood exactly how big things could potentially get in the vacuum of space. You have probably heard the staggering fact that our massive sun could easily fit 1,000,000 Earths inside of its burning volume. You might have even successfully wrapped your head around the mind-bending fact that our Milky Way galaxy stretches across 100,000 light years from one distant side to the other. But I must gently warn you, all of that prior knowledge Every single size comparison you have ever heard or visualized becomes almost entirely meaningless when you learn about the ancient giant that astronomers found hiding in a distant, quiet corner of the endless universe. This giant does not rush, it does not make a sound, it simply exists as a testament to the patient, eternal forces of gravity over deep time. Have you ever looked at a single, flickering star and wondered how far the boundaries of our known reality truly extend? To understand the true majesty of the cosmic scales we are discussing, we must journey back to the moment when humanity first began to open its eyes to the deep dark. When the first primitive telescopes were pointed toward the shimmering band of the Milky Way in the 17th century, early observers experienced a profound revelation. Through the magnifying power of those early glass lenses, they began to realize that the milky glow that had inspired so many ancient myths quietly resolved into countless individual stars. These stars were far too faint and vastly too numerous to ever be seen with the fragile, unaided human eye. This breathtaking realization was the very first gentle hint to our ancestors that our home galaxy was far larger and contained far more stars than anyone throughout human history had ever dared to imagine. It was a quiet shift in our collective perspective, a gentle widening of the boundaries of our known reality, inviting us to peer deeper into the endless, silent void. Yet, even with this expanded vision, for most of human history, we remain gently wrapped in the comforting illusion that this swirling disk of stars was the absolute totality of existence. We genuinely thought our isolated galaxy was the complete universe. This comfortable perception remained undisturbed until the 1920s, when an astronomer named Edwin Hubble stepped forward to gently shatter our localized view of reality. Hubble used the Mount Wilson Observatory located in California, relying upon what was proudly hailed at that time as the largest telescope in the world, a magnificent reflector featuring a mirror 100 inches across. With this incredible instrument, he spent his quiet nights carefully observing a specific class of stars known as Cepheid variables. These unique stars pulse in their brightness with a remarkably regular, predictable period. Hubble was focusing his attention on what was then simply called the Andromeda Nebula, an object most astronomers comfortably assumed was just another local cloud of drifting gas trapped securely within our own Milky Way. By meticulously measuring their apparent brightness against their pulsation rate, Hubble discovered he could calculate exactly how far away those pulsing stars truly were. The mathematical result of his quiet, patient calculations was nothing short of shocking to the human intellect. The gentle light reaching his telescope proved that the Andromeda Nebula was not a simple cloud of glowing gas floating within our own familiar galaxy. Instead, it was an entirely separate, unimaginably distant galaxy, existing roughly 1 million light-years away from us, resting far beyond the furthest outer edges of the Milky Way. It was an island universe of stars in its own right, spinning silently in the dark. In that single, profound moment of discovery, we realized that our galaxy was not the whole cosmos. Rather, it was just one lonely galaxy floating among many. While we now understand that Hubble's original distance estimate was slightly off by about a factor of 2, and that the Andromeda galaxy is actually about 2 million light-years away, his basic, earth-shattering conclusion was entirely correct. The universe was vastly, incomprehensibly larger than anyone had ever imagined, filled not just with stars, but with countless entire galaxies, each one containing billions of its own burning stars. Today, looking through the lenses of our most advanced instruments floating high above the Earth, we estimate that there are around 2 trillion galaxies drifting through the observable universe. Please take a moment to simply breathe in the sheer weight of that number. 2 trillion. That is a 2 followed by 12 completely incomprehensible zeros. Each single one of those distant galaxies contains billions, or perhaps even trillions, of its own ancient stars. As we stare into the deep silence of the cosmos, the numbers become so overwhelmingly large that they simply stop holding any conventional meaning to our earthly human brains. We are faced with a scale of existence that demands complete intellectual humility, inviting us to sit in quiet awe of the majestic architecture of the dark. But within this endless ocean of galaxies, a beautiful and complex diversity emerges, reminding us that nature does not simply copy and paste its creations. Not all galaxies are created equal. In the quiet depths of space, galaxies come in a mesmerizing variety of shapes and enormous sizes. Some are relatively tiny, known as dwarf galaxies, which hold just a few billion stars within their gentle gravitational embrace. Others are massive, majestic spirals, just like our own Milky Way, or our nearest large cosmic neighbor, the Andromeda Galaxy. Spiral galaxies are the most common type found in the nearby universe, gracefully characterized by their distinctive pinwheel arms and flat, rotating disks. These gorgeous structures are typically vibrant sites of active star formation, with brilliant new stars constantly being born within their gas-rich, swirling spiral arms. The beautiful, delicate structure we observe in these spirals is delicately maintained by a perfect cosmic balance between the rotational outward motion of the flat disk and the relentless inward gravitational pull of all the matter held within it. Yet, as we push our gaze further out into the endless dark, we encounter completely different forms of cosmic architecture, each telling its ancient story of gravitational evolution over billions of years. Beyond the graceful spirals, we find elliptical galaxies, which stand as another major classification in the cosmic zoo. Unlike the delicate pinwheels of the spirals, these elliptical galaxies possess no particular internal structure whatsoever. Their shapes range peacefully from nearly perfect smooth spheres to highly elongated, stretched oval shapes. When we peer inside them, we find that they are populated almost entirely by ancient, quiet red stars. Star formation in these elliptical galaxies has largely, permanently ceased, because over the long eons of cosmic time, they have completely exhausted the vast majority of their primordial gas supply. Curiously, when we search for the absolute largest galaxies scattered throughout the universe, we find that they are almost all elliptical in shape, massive structures that were slowly formed through the violent merger of multiple smaller galaxies over billions of years of cosmic history. There are also irregular galaxies floating through the void, which possess no defined, recognizable shape at all. These chaotic collections of stars are very often the direct result of intense gravitational interactions with other nearby galaxies, whose massive gravitational pulls have slowly stretched and distorted their delicate structures over deep time. Even our own night sky holds examples of this, as the Magellanic Clouds, visible floating gently from the southern hemisphere of Earth, are prime examples of irregular galaxies currently being affected by the Milky Way's overwhelming gravity. Furthermore, these island universes are not simply scattered and distributed randomly throughout the endless emptiness of space. Just as people gather in quiet villages and bustling cities, galaxies are highly organized into vastly larger gravitational structures. Galaxy groups are relatively small gatherings that contain anywhere from a simple handful to a few dozen individual galaxies, all held together in a gentle gravitational dance. Our own home, the Milky Way, belongs to what we humbly call the local group, a quiet cosmic neighborhood which contains about 80 known galaxies in total, including the Andromeda Galaxy, and several dozen much smaller dwarf galaxies. Moving up the scale of immensity, we find galaxy clusters, which are significantly larger still, containing hundreds to even thousands of distinct galaxies all tightly bound together by the relentless force of gravity. And finally, representing the absolute largest structures known to exist in all of reality, we find superclusters, which are incredibly vast, mind-bending assemblages of multiple galaxy clusters stretching continuously across hundreds of millions of light-years of seemingly empty space. It is within this mind-expanding context of cosmic structure that we finally meet the true monster of our story, a galaxy so incredibly massive that it firmly sits at the extreme end of the scale. It is a galaxy so enormous, so utterly dominant, that it makes our massive Milky Way look like nothing more than a tiny, insignificant speck of dust floating aimlessly in an impossibly large, empty warehouse. This specific cosmic giant goes by the somewhat boring, unassuming name of IC 1101, a designation which comes from its sequential entry number in a catalog of celestial objects created over a century ago. But please, I urge you, do not let that dull administrative name fool your senses for even a moment. There is nothing boring or ordinary about this silent cosmic giant. IC 1101 sits regally at the exact geometric and gravitational center of a massive cluster of galaxies formerly called Abell 2029, which is located far away in the direction of the constellation Virgo, as seen from our fragile Earth. When astronomers point their telescopes toward this hidden region of the night sky, they see a massive collection of galaxies, bound together by gravity, dancing elegantly around a common center. Right in the heart of that cluster, dominating everything around it, like a silent cosmic emperor resting upon a dark throne, sits IC 1101. This single, breathtaking galaxy is estimated by astronomers to be somewhere around 4 to 6 million light-years across. I invite you to let that immense, quiet fact sink into your mind for a moment. Our Milky Way, which already seemed impossibly large at 100,000 light-years across, is entirely dwarfed by this ancient giant. IC 1101 is roughly 40 to 60 times larger than our entire home galaxy. If you were to gently take IC 1101 and place it exactly where our Milky Way currently sits in the dark, it would not just simply engulf our galaxy. It would completely swallow our entire cosmic neighborhood without making a sound. The Andromeda Galaxy, which floats gracefully about 2.5 million light-years away from us, would suddenly find itself safely tucked entirely inside the massive body of IC 1101. The Triangulum Galaxy, another close neighbor of ours, would also be instantly consumed by its vastness. All of the dozens of smaller dwarf galaxies that orbit around us in the dark, gentle places like the Large Magellanic Cloud and the Small Magellanic Cloud, would simply become tiny, integrated components of this giant's vast, sprawling structure. The sheer scale of this object challenges our deepest understanding of reality, asking us to surrender our earthly perspectives to the infinite cosmos. But physical size is just the very beginning of what makes IC 1101 so deeply incredible and worthy of our gentle wonder. This ancient galaxy is estimated to contain around 100 trillion stars. 100 trillion. Our Milky Way has maybe 400 billion stars at the absolute most. That means This silent giant has roughly 250 times more stars than our entire home galaxy. If you started counting the stars in IC 1101, naming just one single star per second without ever stopping, it would take you over 3 million years just to count to 100 trillion, and that is assuming you never slept, never ate, and never took a quiet break of any kind. Each of those 100 trillion stars is a glowing nuclear furnace burning in the deep silence of space, contributing to a collective glow that is soft, ancient, and endlessly magnificent. They are scattered across millions of light years, a gentle sea of light that has existed for billions of years. The cosmos is filled with these quiet miracles, waiting patiently for us to look up and notice them. The quiet story of how we slowly discovered this cosmic giant begins back in the year 1790, when a German-born British astronomer named William Herschel was systematically scanning the vast night sky with his telescope. Herschel was widely considered one of the greatest astronomers of his era. He had already discovered the pale planet Uranus several years earlier, and he spent much of his quiet life cataloging thousands of celestial objects that no human eyes had ever documented before. On June 19th of that year, Herschel pointed his telescope toward a specific region of the sky in the constellation Virgo and noticed a very faint, fuzzy blob of soft light. He carefully and quietly recorded its position in his notes and gently moved on to the next object in the dark. At that moment in time, Herschel had absolutely no way of knowing what he was actually looking at. The technology simply did not exist to measure how incredibly far away this object truly was. The scientific understanding of the era did not exist to recognize that it was an entire, independent galaxy, completely separate from our own. He simply logged it as another mysterious nebula, one of many cloud-like objects scattered across the heavens. For over a century, that faint smudge of ancient light remained a deep, unresolved mystery. It sat there in the astronomical catalogs, a quiet whisper from the deep universe, waiting for our collective knowledge to finally catch up to its majestic reality. Everything gracefully changed in the 20th century when astronomers developed much better telescopes and bold new techniques for measuring vast cosmic distances. They finally discovered that IC 1101 was not a simple cloud of drifting gas within our own galaxy. It was an entirely separate galaxy, mind-bogglingly far away. The delicate light we see from IC 1101 today actually left that galaxy over 1 billion years ago. It has been traveling silently through the absolute void of space for more than 1 billion years, just to reach the glass lenses of our waiting telescopes. Think about the profound journey of those ancient photons, when that light first began its gentle journey toward us. Life on Earth consisted mostly of simple, single-celled organisms drifting in primordial oceans. Complex animals had not yet evolved, and the great dinosaurs would not appear for another several 100 million years. Every single major event in human history happened while that ancient light was still quietly crossing the unimaginable emptiness between galaxies. As Carl Sagan once beautifully observed, the cosmos is all that is, or ever was, or ever will be. That light is a silent messenger from deep time, carrying the secrets of a universe much older and much grander than our daily lives might ever suggest. As astronomers continued their patient study of IC 1101, they slowly began to uncover the deep mystery of why it was so incredibly massive. The universe is a place of endless transformation, and this galaxy did not grow to its enormous, mind-bending size through normal, peaceful processes alone. It became a silent giant through a slow, majestic act of cosmic assimilation that has been happening steadily for billions of years. IC 1101 is what scientists call a cannibal galaxy, meaning it has spent eons gently consuming other galaxies. To truly understand galactic cannibalism without feeling intimidated, you need to simply think about how gravity works on the largest scales of the cosmos. Galaxies do not exist in perfect isolation. They are deeply social entities, naturally grouped together in vast clusters, held together by their mutual gravitational attraction. Within these peaceful clusters, galaxies perform a beautiful, incredibly slow dance, moving around each other, sometimes passing close by, and sometimes colliding directly in the endless dark. When two galaxies drift close to each other, their combined gravity gently begins to distort their beautiful shapes. Stars get slowly pulled out of their normal, predictable orbits, while vast clouds of gas and dust get beautifully compressed and stretched across the void. If the two interacting galaxies are relatively similar in their overall size, they might gracefully merge together over hundreds of millions of years, eventually forming a single, beautifully blended, larger galaxy. But if one galaxy happens to be significantly much bigger than the other, something entirely different and quite profound happens. The larger galaxy simply and quietly absorbs the smaller one, stripping away its ancient stars and primordial gas, gracefully adding all of that cosmic material to its own massive, growing body. This gentle but relentless process is exactly what has been happening to IC 1101 for billions of years. As the absolute largest and most massive galaxy residing in its cluster, IC 1101 sits comfortably at the deep gravitational center of everything around it. Smaller, wandering galaxies that venture just a little too close gently get trapped by its enormous, inescapable gravity. They slowly spiral inward, getting softly pulled apart and utterly consumed over millions of years of silent cosmic time. Each quiet meal makes IC 1101 just a little bit bigger, a little bit more massive, and a little bit more dominant in the dark. Scientists have carefully estimated that IC 1101 has quietly undergone at least 76 major mergers over its incredibly long, ancient history. 76 times another substantial, beautiful galaxy gently fell into this cosmic giant and was seamlessly absorbed into its massive body. And those are only the major mergers. Countless smaller, fragile dwarf galaxies have also been softly consumed along the way. These smaller galaxies were so delicate that they barely registered as a cosmic event for this enormous, silent gatherer of stars. All of those slow collisions, all of that patient gravitational chaos, has gently stirred up the ancient stars like someone softly mixing ingredients in an impossibly large cosmic bowl. What remains today for us to observe is this perfectly smooth, featureless giant, standing as a beautiful, silent testament to billions of years of galactic gathering in the quiet dark. But there is something even more deeply remarkable about IC 1101, a gentle paradox that challenges our intuitive understanding of cosmic vitality. Despite containing the unimaginable wealth of 100 trillion stars, this majestic giant is actually, in the quietest sense of the word, a dying galaxy. The stars that populate its vast, sprawling body are almost entirely ancient. Most of them are what astronomers affectionately call red giants or steady yellow stars, ancient stellar objects that have already patiently burned through the vast majority of their primordial nuclear fuel. Very few new bright stars are being born inside the gentle embrace of IC 1101 today. This reality might seem quite strange at first glance. With so many trillions of stars and so much gathered mass, you might reasonably expect this galaxy to be a vibrant, chaotic hotbed of constant stellar birth and activity. But to understand this quiet fading, we must remember exactly how it grew so unimaginably large in the first place. Every single time it slowly consumed another wandering galaxy over the eons, it also consumed that galaxy's precious, finite gas supply. In the delicate chemistry of the cosmos, cool gas is the fundamental, necessary fuel for star formation. Without drifting clouds of gas, beautiful new stars simply cannot be born. Over billions of years of silent, relentless assimilation, IC 1101 has carefully used up or forcefully expelled almost all of its available gas. The immense mergers themselves were often physically violent enough to heat the remaining gas to absolutely extreme temperatures, making it rapidly expand and escape the galaxy's gravitational grip entirely, or to compress it so incredibly quickly that it all formed into stars at once, in brief, intense, magnificent bursts of ancient activity. Either way, the gentle end result is a quiet galaxy that has completely run out of raw, creative material. What remains today is a silent giant, slowly and gracefully fading into the eternal cosmic night. Let us contemplate the profound patience of these ancient stars. The stars that exist now within this sprawling giant will continue to shine with a soft, enduring light for billions of years to come. But as they eventually, inevitably burn out and gracefully die, slipping into the dark, there will be absolutely no new generations of bright stars to replace them. IC 1101 is much like a magnificent ancient kingdom that has successfully gathered all of its neighbors into a peaceful, unified whole, but sadly has no children to carry on its grand cosmic legacy. It is unthinkably massive, gravitationally powerful, and utterly magnificent in its scale. But it is also quietly approaching the gentle end of its active, vibrant life, settling into a long, eternal slumber. The most numerous stars remaining within its vast halo are tiny red dwarfs. These unassuming dim stars are so small that they burn their nuclear fuel incredibly slowly, allowing them to shine peacefully for trillions of years. For eons after the larger, brighter stars have all died out, these countless red dwarfs will continue to burn, providing the only soft, gentle light in an otherwise darkening galaxy. They are the patient timekeepers of the cosmos, marking the passage of ages that make the current lifespan of our universe seem like nothing more than the blink of an eye. Yet, at the very heart of IC 1101, resting quietly in the exact center of all those fading stars, lies something even more deeply incredible than the galaxy itself. Sitting perfectly still at the gravitational center of this cosmic giant is one of the absolute largest known supermassive black holes in the entire observable universe. As we have learned through decades of patient observation, almost every large galaxy harbors a supermassive black hole at its deep core. Our own familiar Milky Way has a relatively modest one called Sagittarius A star, which contains about 4 million times the mass of our own Sun. The black hole resting at the center of the neighboring Andromeda galaxy is significantly bigger, containing somewhere around 100 million to 200 million solar masses. But the silent entity at the center of IC 1101 exists in a completely different, almost terrifying category of immensity. Scientists have carefully estimated that this single central object contains somewhere between 40 billion and 100 billion times the mass of our Sun. I want you to pause and rest with that thought. This single, quiet black hole might easily possess 25,000 times more mass than the black hole at the center of our entire Milky Way galaxy. Let me try to gently help you understand just how unimaginably massive this truly is. If you could somehow magically place the Earth on a cosmic scale, you would find it has a staggering mass of about 6 trillion kilograms. That sounds like an impossibly large amount, until you humbly compare it to our Sun, which is roughly 330,000 times more massive than the Earth. Our Sun is a beautiful, life-giving, but fairly ordinary star, neither particularly large nor particularly small by the vast standards of the cosmos. Now, I ask you to take the mass of our Sun and multiply it by 50 billion. That incomprehensible number represents roughly how much physical mass is tightly packed into the supermassive black hole at the silent center of IC 1101. All of that incredible mass is permanently compressed into a mysterious region of space from which absolutely nothing, not even a single photon of light, can ever hope to escape. The gravitational pull precisely at the event horizon, which is the invisible, defining boundary of the black hole, is so unfathomably intense that light itself is pulled back inward. The physical size of any black hole's event horizon depends entirely upon its mass. For a monstrous black hole containing 50 billion solar masses, the event horizon would possess a radius of roughly 150 billion kilometers. That vast distance might sound enormous, and it truly is. But please remember that this is a defined region containing 50 billion times the mass of the Sun, all compressed down into what is essentially a single, infinitely dense point at the exact center. The event horizon is merely the quiet, dark boundary beyond which escape becomes a physical impossibility. To place this immense scale into a perspective that our minds can gently hold, consider that our entire solar system, stretching from the warmth of the Sun all the way out to the freezing orbit of Neptune, is only about 9 billion kilometers across. This means that the event horizon of IC 1101 central black hole is roughly 16 times larger than our entire solar system. If you were to gently place this ancient black hole exactly where our Sun is right now, its dark event horizon would easily extend far beyond the distant orbit of Pluto, completely and silently engulfing everything we have ever known or considered to be our cosmic home. What would it truly be like to drift near this monstrous silent entity? The physics of such extreme, distorted environments is wonderfully bizarre and deeply counterintuitive to our everyday earthly experiences. Time itself, that steady marching rhythm we set our lives by, would pass entirely differently near the edge of the event horizon compared to a safe distance far away. If an observer were somehow falling slowly toward the black hole, they would look out and see the entire outside universe appear to dramatically speed up. Meanwhile, a completely safe outside observer watching from far away would see the falling person seemingly slow down, their movements becoming ever more sluggish until they appeared to freeze perfectly still as they approached the final horizon. From the perspective of the outside universe, they would never seem to actually cross that final, dark boundary. Inside the event horizon, reality itself bends. All physical directions invariably lead inward toward the singularity at the center. Space and time themselves become so fundamentally warped and twisted that the very concept of escaping becomes entirely meaningless. But here is a gentle, comforting truth about this magnificent cosmic structure. Despite its enormous, awe-inspiring size and its seemingly terrifying properties, the supermassive black hole at the center of IC 1101 is currently resting, remaining relatively quiet. It is not actively devouring huge, violent amounts of cosmic matter. There is no brilliant, swirling accretion disk of burning gas spinning around it. There is no incredibly powerful, blinding jet of energy shooting out into the deep void of space at nearly the speed of light. The great black hole is simply there, waiting patiently in the dark, because over the billions of years of its long existence, it has already calmly consumed most of the available material that was easily within its gravitational reach. This profound quietness is deeply and intimately related to the exact same phenomenon that has gently stopped the rest of IC 1101 from forming any new stars. Most of the drifting gas in the galaxy has already been completely used up or pushed away, and without new gas drifting inward toward the center, the great black hole has very little left to eat. Occasionally, a wandering star might drift just a little too close in the dark and get softly torn apart, providing a brief, brilliant meal. But on the cosmic timescale, these gentle events are exceedingly rare. The black hole, very much like the ancient, sprawling galaxy that hosts it, is a magnificent giant resting in deep repose, powerful beyond measure, but entirely dormant in the silent dark. It is a monument to a much more chaotic past, now sitting in absolute stillness, inviting us to contemplate the deep, unending quiet of the infinite cosmos. Have you ever walked alone on a quiet, fog-draped morning and wondered if the solid ground beneath your feet is truly as absolute and unchanging as it appears to be? We spend our entire lives moving through a world that feels incredibly reliable, where objects fall predictably to the ground, where the gentle ticking of a clock measures time in steady, unbreakable rhythms, and where the boundaries of our physical reality seem perfectly defined. But what if I told you that this comforting solidity is merely a beautiful, elaborate illusion? I invite you to leave the noise of the day behind, to take a quiet breath, and to join me on a journey not up into the vast, sprawling darkness of the cosmos, but downward, deep into the invisible, microscopic architecture of reality itself. Let us venture together into the ancient mystery of the quantum realm, where the fundamental rules of our universe gracefully unravel, leaving behind a gentle, imposing wonder that even the brightest minds on our planet are still struggling to comprehend. Beneath the quiet, rolling green hills that rest gently on the border between France and Switzerland, an enormous ring of superconducting magnets lies buried in the deep silence of the Earth. This is the European Organization for Nuclear Research, known to the world simply as CERN. Here, wrapped in the cold, ancient dark of the subterranean world, humanity has constructed the largest and most complex machine ever conceived by our species. The Large Hadron Collider is a marvel of human curiosity, a 27-kilometer circle of unparalleled engineering designed to accelerate microscopic particles to a fraction of a whisper below the absolute speed of light. It was built with a single, beautiful purpose: to recreate the exact conditions that existed just a billionth of a second after the primordial birth of our universe. Through the careful, deliberate smashing of protons, scientists hope to catch a fleeting, ghostly glimpse of the fundamental building blocks of all matter. It is a quiet temple of modern science, a place where we ask the universe the most profound questions about its own origin. As the brilliant astronomer Carl Sagan once elegantly noted, Science is not only compatible with spirituality, it is a profound source of spirituality. And nowhere is this gentle truth more apparent than in the sterile, echoing tunnels of CERN, where the boundary between physics and philosophy gracefully dissolves into the quantum mist. For decades, this massive, quiet instrument has provided us with extraordinary revelations about the nature of our physical world. It confirmed the existence of the Higgs boson, the elusive, invisible particle that grants mass to everything in the universe, from the towering, ancient mountains on our planet to the distant, swirling galaxies observed by the dedicated explorers at NASA and the European Space Agency. Through these magnificent discoveries, we thought we were slowly, carefully putting together the ultimate puzzle of reality, fitting each subatomic piece into a neat, predictable framework known as the Standard Model of Particle Physics. We felt a quiet sense of intellectual safety, a comforting belief that the deepest, most complex mysteries of the cosmos were finally yielding to our patient, collective inquiry. We mapped the forces of electromagnetism, and we traced the delicate interactions of the strong and weak nuclear forces that hold the very cores of atoms together. But the universe, in its endless, quiet majesty, always holds secrets that defy our most confident assumptions. There are moments when the cosmos gently pushes back against our understanding, reminding us that we are merely curious children standing on the shores of an infinitely vast and unexplored ocean. The more we learn, the more we realize how deeply the shadows of the unknown stretch into the infinite horizon. It happened during what was supposed to be a perfectly routine, quiet observation run. The colossal detectors, weighing thousands of tons and packed with millions of delicate sensors, were silently watching the microscopic aftermath of countless proton collisions. These detectors are like giant, complex electronic eyes, designed to capture the brief, beautiful flashes of exotic particles that bloom into existence and then fade away in a fraction of a billionth of a second. The scientists sitting in the quiet control rooms, surrounded by glowing screens and humming computers, were expecting to see the familiar, well-understood patterns of decay. Instead, the data began to whisper something entirely unexpected. Deep within the chaotic, microscopic debris of the quantum collisions, an anomaly appeared. It was not a loud, catastrophic failure of the machinery, nor was it a simple, easily explained mathematical error. It was a gentle, persistent deviation in the data, a subtle but undeniable tear in the very fabric of our physical models. Something had been created in the dark heart of the detector that simply should not exist, and it refused to follow the rules we had so carefully written. The particles that emerged from this specific, mysterious collision behaved in a way that defied every single rule written in our textbooks. They did not decay into the predictable, familiar fragments we have mapped over decades of rigorous study. Instead, they seemed to hesitate, lingering in the quiet vacuum of the detector for a microscopic eternity before vanishing without leaving the expected energetic signatures. It was as if these particles had momentarily slipped into a completely different dimension, or as if they were interacting with a hidden, invisible force that permeates the deep silence of the quantum void. The physicists analyzing the data were left in a state of profound, respectful wonder. They checked their calibrations, they meticulously reanalyzed the vast streams of information, and they searched desperately for any mundane explanation that could account for this bizarre, ghostly behavior. But the anomaly remained, a quiet, stubborn fact resting at the very edge of human knowledge. It was a gentle reminder that for all our technological prowess and mathematical brilliance, the universe still harbors deep, ancient mysteries that can effortlessly shatter our most fundamental paradigms. This subtle, inexplicable event at CERN forces us to confront a deeply humbling realization about our place in the natural order. We look up at the vast, sprawling cosmos, marveling at the hundreds of billions of galaxies that float in the endless night. And we often feel incredibly small, almost insignificant, against the backdrop of deep time. Yet, when we peer downward into the microscopic heart of a single atom, we find an inner universe that is just as endlessly complex, just as impossibly vast, and just as deeply mysterious as the infinite spaces between the stars. The quantum realm operates on rules that seem like pure magic to our earthly senses, completely defying the comforting logic we rely upon to navigate our everyday lives. It is a place where particles can exist in multiple places at the exact same moment in a gentle blur of probability, where objects can be mysteriously entangled across vast distances, communicating in total silence faster than the speed of light, and where the mere act of observation by a conscious mind can fundamentally alter the physical nature of reality itself. The astrophysicist Neil deGrasse Tyson once beautifully stated that the universe is under no obligation to make sense to you. This gentle truth echoes profoundly through the silent underground tunnels of CERN, where the brightest minds of our generation are standing at the absolute precipice of the unknown, gazing into a quantum abyss that completely refuses to yield its deepest, most ancient secrets. It is a frontier that demands not just mathematical precision, but a profound philosophical surrender to the beautiful strangeness of existence. As we sit here in the quiet comfort of our daily lives, it is easy to forget that we are suspended between two incomprehensible infinities. Above us, the majestic, ancient cosmos stretches out into a dark, endless silence, filled with ancient stars and drifting galaxies. Below us, the microscopic fabric of reality seethes with quantum probabilities, a shifting, invisible landscape where the rules of cause and effect gently dissolve. The inexplicable anomaly discovered deep beneath the earth is not a failure of our science. It is a beautiful, open door inviting us to step into a wider, more profound understanding of existence. It teaches us the vital importance of intellectual humility, reminding us that true wisdom begins precisely at the moment we peacefully accept how little we truly know. This tier in our understanding is not something to be feared, but something to be celebrated, for it guarantees that our journey of discovery is far from over. There will always be new mysteries waiting in the dark, new questions calling to us from the deep silence. As we prepare to delve deeper into the specific, mind-bending details of what exactly went wrong during that quiet experiment, I invite you to hold on to this gentle sense of wonder. Let the mystery calm your mind, knowing that we are all simply curious passengers on a tiny, beautiful world, forever trying to understand the endless, majestic architecture of the universe that gave us life. Have you ever paused during a quiet evening, perhaps while watching the gentle fall of autumn leaves, or the slow, deliberate drift of clouds across a twilight sky, and wondered about the invisible threads that hold our reality together? We are so wonderfully accustomed to the macroscopic world, a world of tangible objects, predictable gravity, and comforting solidity. We trust implicitly that the ground will always support our weight, and we believe that the physical laws governing our daily lives are absolute and eternal. Yet, the deeper we look into the fundamental fabric of the cosmos, the more we gently realize that this comforting solidity is merely a beautiful facade, a delicate illusion painted over a reality that is infinitely more complex and mysterious. I invite you to settle into a quiet, comfortable space, to let go of the rigid expectations of the everyday world, and to continue our journey into the microscopic abyss. Let us explore the precise nature of the anomaly that whispered from the deep, dark depths of the Large Hadron Collider, a gentle but profound deviation that has left the world's most brilliant quantum scientists resting in a state of respectful, awe-filled silence. To truly appreciate the magnitude of this quantum mystery, we must first gently understand the magnificent instruments that stand as our silent sentinels in the dark, deep underground, spanning the borders of peaceful nations, rest the colossal detectors of the European Organization for Nuclear Research, machines with names that sound almost mythic in their ambition. These are not simply cameras or conventional microscopes. They are vast modern cathedrals of human science, intricately designed to capture the fleeting ghosts of the quantum world. Imagine a machine the size of a 5-story building, packed with millions of delicate microscopic sensors, all working in perfect, silent harmony in the cold subterranean dark. When protons collide at nearly the speed of light within the metallic heart of these detectors, they shatter violently into a beautiful shower of exotic, incredibly short-lived particles. These particles exist for only a fraction of a billionth of a second before decaying into much more stable forms, leaving behind delicate, invisible trails of pure energy. The massive detectors act as a vast three-dimensional net, catching these fleeting whispers and seamlessly translating them into massive streams of digital data. It is a slow, patient process of unearthing the ancient, primordial secrets of the universe, one microscopic collision at a time. For decades, these silent detectors have beautifully and consistently confirmed the elegant mathematical framework we affectionately call the Standard Model of particle physics. The Standard Model is, in many wonderful ways, the absolute crown jewel of human intellect, a deeply successful theory that describes the fundamental particles and forces that weave the intricate tapestry of our known universe. It has predicted the existence of quarks, leptons, and bosons with an astonishing, almost terrifying accuracy that has guided physicists for generations. It is a comforting rulebook, a scientific compass that has guided us safely through the strange, chaotic wilderness of the quantum realm. When scientists deliberately smash protons together, they use the Standard Model to predict exactly what kind of particles should emerge and precisely how they should decay into the void. It is very much like listening to a grand cosmic symphony where every single note has been written meticulously in advance. We know exactly when the violin should gently swell and when the heavy percussion should strike. But science is not a closed, finished book, and the universe is absolutely under no obligation to perfectly match our mathematical symphonies. The anomaly that quietly shattered this comforting paradigm emerged from the data collected by a specific experiment, a massive detector specifically designed to study a peculiar, beautiful type of particle known to physicists as the B meson. B mesons are exotic, highly unstable particles that contain a heavy particle known as a beauty quark or a bottom quark. They are created in the chaotic, microscopic aftermath of high-energy proton collisions and exist for barely a flicker of time before they naturally and inevitably decay into a cascade of lighter, more familiar particles. According to the ancient, deeply established rules of the Standard Model, there is a fundamental principle called lepton flavor universality. This principle acts as a sort of gentle cosmic democracy within the quantum realm. It clearly dictates that when these heavy B mesons decay, they should produce ordinary electrons, and their heavier, slightly more mysterious cousins, muons, with absolute, perfect equality. The universe, according to our deeply trusted rulebook, should not show any preference whatsoever between the two. The microscopic decay paths should be a perfectly balanced scale, resting in eternal mathematical harmony. But as the dedicated scientists sat in their quiet, humming control rooms, carefully sifting through the massive mountains of data generated by billions of quiet collisions over many years, the cosmic scale began to gently, inexplicably tip. The data began to whisper a story that completely contradicted the established, comforting harmony of lepton flavor universality. When the B mesons decayed in the cold, dark heart of the detector, they were not producing electrons and muons in equal measure at all. Instead, there was a subtle, persistent, undeniable deficit of muons. The universe, it seemed, was secretly favoring the creation of electrons, acting with a hidden, invisible bias that completely broke the golden rules of the Standard Model. It was a deviation so incredibly small that it could easily have been initially dismissed as a simple statistical fluctuation, a gentle whisper of random noise in a vast ocean of information. But as the complex experiment ran for months, and then for years, the anomaly simply refused to fade away into the background. It stood there in the silent data, a stubborn, beautiful truth that demanded to be seen, acknowledged, and understood. The slow realization of what this imbalance truly meant sent a quiet electric shockwave through the global community of physicists. If lepton flavor universality is truly broken, it means that our fundamental understanding of the universe's most basic building blocks is profoundly incomplete. It means that there is a hidden mechanism, a secret, invisible gear turning in the deep machinery of reality that we have never noticed before in all our decades of searching. Some scientists began to softly theorize that this anomaly was the ghostly signature of an entirely new, undiscovered particle, perhaps a hypothetical entity that could elegantly bridge the mysterious gap between quarks and leptons. Others whispered of a heavy, silent messenger particle carrying an entirely new, fifth fundamental force of nature, a force that has existed in the dark since the very dawn of time, gently pulling the invisible strings of the quantum world, completely undetected by human senses or our most advanced machinery until this very quiet moment in human history. Imagine, for a quiet moment, the profound implications of discovering a fifth fundamental force. We are intimately familiar with gravity, which anchors us gently to the earth and holds the swirling, ancient galaxies in their majestic cosmic dance across the void. We understand electromagnetism, which lights our homes and allows our hearts to rhythmically beat. We have carefully mapped the strong and weak nuclear forces that bind the very cores of ancient stars and atoms alike. But the possibility of a fifth force operating in the deep, silent shadows of the quantum vacuum suggests that our universe is far richer, far more complex, and far more deeply interconnected than we ever dared to dream. It is a gentle reminder that the reality we perceive every day is only the fragile surface of a vast, unfathomable ocean. Beneath the calming waves of our everyday experience, there are ancient, hidden currents flowing through the dark, waiting patiently to be discovered by those brave enough to look deeper into the infinite mystery. This gentle unraveling of the Standard Model is not a crisis of science. Rather, it is the most beautiful, pure expression of the scientific journey. It is the breathtaking moment when the cosmos graciously hands us a new, profound mystery, inviting us to step entirely beyond the comforting borders of our current knowledge. When we encounter phenomena that we cannot easily explain, we are gently forced to shed our intellectual arrogance and embrace a profound, quiet humility. The scientists at CERN are not angry or defeated by this persistent anomaly. They are deeply invigorated, filled with a respectful wonder and a deep, burning curiosity that drives human progress. They are the modern explorers of an invisible cosmos, charting territories that exist purely in the abstract realm of mathematics and quantum probability. Their confusion is not a sign of failure, but a beautiful sign that they are finally touching the true, raw edge of human comprehension, staring directly into an infinite expanse of undiscovered truth. As we contemplate this quantum mystery, we can find a strange, gentle peace in the realization that we do not have all the answers. In a modern world that constantly demands certainty and absolute resolution, the quiet, persistent mysteries of the cosmos offer a soothing sanctuary for our restless minds. It is profoundly beautiful to acknowledge that the universe is larger, older, and vastly more mysterious than our human intellects can currently grasp. The anomaly at CERN is a silent, microscopic reflection of the exact same wonder we feel when we gaze up at the unimaginable vastness of the largest galaxies. Whether we are looking out across billions of light years of silent space, or looking down into the ephemeral, ghostly decay of a single subatomic particle, we are encountering the exact same infinite, majestic reality. We are an integral part of a universe that is constantly whispering its secrets to those who take the quiet time to simply listen to the silence. The journey of discovery is an endless, winding path through a vast forest of profound mysteries. Just as we comfortably thought we had finally reached a clearing, a place of comforting, illuminated certainty with our established physics, the universe gently nudged us back into the beautiful, shadowed unknown. It quietly reminded us that the book of nature is never truly finished. There are always new pages to turn, new languages to decipher, and new, breathtaking concepts to explore. The inexplicable events happening in the dark tunnels beneath the earth are an open invitation to every curious mind on this planet. They remind us that the grand age of discovery is not relegated to the dusty pages of history. It is happening right now in the silent, invisible spaces all around us. We are all passengers on this wondrous journey, moving forward together into an expanding frontier of knowledge that promises to gently change everything we thought we knew. As we let these complex, mind-bending thoughts settle gently in our minds, I invite you to find comfort in the vast, open spaces of the unknown. The universe is holding on to its deepest secrets with a gentle, patient grip, revealing them only when we are truly ready to understand the magnitude of their implications. In our next step, we will venture even deeper into the theoretical shadows, exploring the mind-bending possibilities that this quantum anomaly has unlocked for human understanding. We will look at how hidden dimensions, microscopic black holes, and the very fabric of space-time itself might be conspiring to create the strange, ghostly behaviors observed in the dark. Until then, take a quiet breath, feel the reassuring weight of the earth beneath you, and allow yourself to simply marvel at the endless, beautiful complexity of the cosmos. The journey is infinite, and the mystery is our most precious, gentle guide. Have you ever held a perfectly smooth, fragile autumn leaf in your hand and wondered about the invisible, complex architecture that allows it to simply exist? We move through a world that we firmly believe is entirely defined by three simple dimensions of space, moving strictly forward in a single, unyielding dimension of time. We walk forward, we step sideways, we climb upward, and we constantly march into tomorrow. It is a comforting, predictable box that safely contains all of our human experiences. But what if I gently suggested to you that this familiar box is actually an illusion, a severely limited perception of a reality that is infinitely more complex, folded, and layered than our human senses could ever possibly detect? I invite you to settle into a quiet, peaceful state of mind, leaving the familiar boundaries of your day behind. Let us embark on a journey further into the theoretical shadows of the quantum realm, exploring the mind-bending possibilities that the brilliant scientists at CERN are carefully considering to explain the inexplicable anomaly that shattered their expectations. Let us listen closely to the profound silence of the invisible universe, where the answers to our deepest mysteries might be hiding in dimensions we cannot even begin to see. As we gently recall the anomaly from the deep underground tunnels of the Large Hadron Collider, we remember the subtle, persistent deficit of muons during the beautiful decay of the heavy B mesons. The universe was secretly favoring electrons, acting with a hidden bias that completely broke the established rules of the standard model of particle physics. The missing energy, the ghostly imbalance in the mathematical equations, led some of the most brilliant physicists on our planet to softly whisper a truly astonishing question. What if those missing particles did not simply cease to exist, but instead slipped quietly away into a dimension that we cannot perceive? To understand this breathtaking concept, we must take a gentle step into the realm of string theory, a magnificent, elegant mathematical framework that attempts to describe all the fundamental forces and particles of the cosmos as incredibly tiny, vibrating loops of pure energy. According to this ancient, beautiful theoretical architecture, the familiar particles we study are not merely solid dots, but delicate cosmic notes playing on microscopic, invisible strings. And for the mathematics of this grand cosmic symphony to perfectly resolve, the universe must possess far more dimensions than the simple three we experience every single day. Imagine, for a quiet moment, a very thin, incredibly long cable stretching between two tall buildings against a twilight sky. From a vast distance, looking through the gentle haze of the evening, that cable appears to be nothing more than a simple one-dimensional line. If you were a tightrope walker stepping carefully upon it, you could only move forward or backward along its length. But if you were to look much closer, perhaps through the eyes of a tiny, quiet ant resting upon that very same cable, you would realize that it also possesses a second, hidden dimension. The ant can easily walk entirely around the circular circumference of the cable, moving in a direction that is completely invisible and inaccessible to the distant observer. In a remarkably similar, deeply poetic way, quantum physicists propose that there are extra dimensions of space, perhaps as many as 6 or 7 additional spatial dimensions, that are curled up and tightly folded upon themselves at a scale so incomprehensibly microscopic that we simply cannot perceive them. These hidden dimensions are woven into the very fabric of every single point in space, resting in profound silence right beside us, holding secrets that have remained undisturbed since the primordial dawn of the universe. When the colossal magnets at CERN smash protons together at nearly the speed of light, they are momentarily concentrating an unimaginable amount of energy into an infinitesimally small, quiet point in space. It is theoretically possible that during these violent, microscopic collisions, the rigid barriers between our familiar dimensions and those tightly curled hidden dimensions are ever so gently breached. The particles that seem to behave so strangely, or The energy that appears to simply vanish from our most sensitive detectors might actually be momentarily slipping into those invisible, extra-spatial dimensions. They leak away from our reality like water softly seeping through a microscopic crack in a glass vase, only to return a billionth of a second later, forever altered by their brief journey through the hidden topology of the cosmos. This gentle leakage of gravity or exotic particles into extra dimensions could perfectly explain why the bee mesons are not decaying according to our familiar, comforting rules. The anomaly is not a mistake. It is a quiet, profound message from a larger, multidimensional universe, respectfully reminding us that our human perspective is beautifully, terribly limited. But hidden dimensions are not the only magnificent possibility waiting in the theoretical dark. There is another, perhaps even more, mind-bending concept that physicists are carefully considering to explain the strange, ghostly behaviors witnessed in the underground detectors. What if the massive collisions at the Large Hadron Collider are momentarily creating microscopic, ephemeral black holes? When we hear the term black hole, our minds immediately picture the enormous silent monsters resting at the centers of ancient galaxies, like the supermassive giant we explored earlier, containing tens of billions of solar masses and swallowing entire star systems in the deep night. But the mathematics of quantum mechanics allow for the possibility of primordial, microscopic black holes, incredibly tiny gravitational wells that can form when immense energy is packed into a space much smaller than a single atom. These quantum black holes would not be terrifying destroyers of worlds. Rather, they would be delicate, fleeting miracles of extreme physics, existing for a fraction of a blink of an eye before gracefully evaporating back into the quiet vacuum of space. The brilliant theoretical physicist Stephen Hawking famously discovered that black holes are not perfectly, eternally black. Due to the incredibly strange, beautiful laws of quantum mechanics operating near their event horizons, they slowly and quietly emit a faint, steady stream of thermal energy, a phenomenon we now respectfully call Hawking radiation. For a massive, galactic black hole, this evaporation process takes trillions upon trillions of years, a span of time longer than the current age of the cosmos itself. But for a microscopic quantum black hole created in the heart of a particle accelerator, this evaporation would happen almost instantaneously. In a brilliant, microscopic flash of Hawking radiation, the tiny black hole would decay into a beautiful, chaotic shower of fundamental particles. If such microscopic black holes are indeed being momentarily formed and subsequently evaporating within the detectors at CERN, their complex, unpredictable decay paths could easily skew the delicate data, creating exactly the kind of strange, unbalanced anomalies that have left scientists resting in a state of respectful wonder. The missing muons might simply be the chaotic, beautiful signature of a quantum black hole, gently breathing its last breath in the cold dark. The journey to understand the fundamental nature of reality is not a race to a final, definitive answer. It is a slow, quiet, endless exploration of an infinite landscape, a journey that honors the beautiful tension between the known and the unknown. As we sit here together in the quiet safety of the present moment, surrounded by the comforting illusion of our three-dimensional world, we can take a deep, peaceful breath, knowing that there is so much more to existence than meets the eye. The universe is holding its secrets with a gentle, patient grace, waiting for us to develop the wisdom and the tools necessary to truly comprehend them. In our next step together, we will explore the philosophical implications of living in a universe that constantly rewrites its own rules. Let your mind rest in the vast, quiet expanse of the possible. Look around you and gently remember that the invisible, ancient magic of the cosmos is silently resting in every single point of space, holding the universe together in a masterpiece of unimaginable wonder. Have you ever stood quietly by the edge of a vast ancient ocean at midnight, feeling the gentle rhythmic pull of the tides, and wondered about the invisible force that orchestrates such magnificent movement? We experience gravity every single day of our lives. It is the comforting anchor that holds us safely to the earth, the silent tether that keeps our fragile moon in its eternal orbit, and the majestic architect that shapes the sprawling galaxies we observe in the deep dark. Yet, for all its profound influence over the cosmos, gravity remains the most deeply mysterious and isolated of all the fundamental forces. It is incredibly, almost incomprehensibly weak when compared to the vibrant forces that govern the microscopic world. If you simply pick up a small metal paperclip with a tiny common magnet, you are successfully defeating the combined gravitational pull of the entire Earth. This gentle paradox has troubled the greatest minds in physics for generations, pointing toward a profound disconnect in our understanding of reality. As we continue our journey deeper into the quantum mysteries revealed by the anomaly at CERN, we must softly turn our attention to the ultimate prize of modern science, the beautiful, elusive dream of unifying the macrocosm and the microcosm into one single, elegant, mathematical truth. To appreciate the depth of this challenge, we must first gently explore the two towering pillars of modern physics, which currently stand completely separated by an invisible wall. On one side, we have the breathtaking genius of Albert Einstein and his theory of general relativity. Einstein beautifully reimagined gravity not as a simple, invisible tether, but as the gentle curving and warping of the very fabric of space-time itself. Imagine a perfectly smooth, tightly stretched trampoline, silent and still. If you gently place a heavy bowling ball in the exact center, the fabric smoothly dips and curves downward. If you then roll a smaller marble across the trampoline, it will naturally follow the curve created by the heavier ball, spiraling inward. In this magnificent, elegant vision of the cosmos, the universe is a smooth, continuous, predictable landscape. It is a reality of graceful curves and sweeping trajectories, where the ancient, silent galaxies and supermassive black holes dictate the beautiful geometry of existence over billions of years. It is a deeply comforting, majestic framework that perfectly describes the universe on its absolute largest scales. But when we gently turn our gaze away from the stars and look downward into the microscopic heart of matter, we encounter the second towering pillar, the strange, chaotic, and entirely unpredictable world of quantum mechanics. As we have seen in the silent, underground tunnels of the Large Hadron Collider, the quantum realm does not operate smoothly or continuously. It is a turbulent, restless ocean of probabilities, where energy exists in discrete, indivisible packets called quanta. It is a place of sudden leaps, ghostly entanglements, and fundamental uncertainty. In the quantum world, the smooth fabric of space-time envisioned by Einstein breaks down completely, dissolving into a violent, frothing foam of microscopic fluctuations. For decades, physicists have desperately tried to merge these two beautiful, successful theories together, hoping to create a single, unified theory of quantum gravity. But every single time they attempt to combine the smooth mathematics of relativity with the choppy, discrete equations of quantum mechanics, the calculations spectacularly break down, yielding impossible, infinite answers. The universe firmly refuses to let us see the complete picture, keeping its two magnificent realms separate in the dark. This is precisely why the gentle, persistent anomaly, discovered deep within the detectors at CERN, is so incredibly, profoundly exciting. The strange behavior of the B mesons, the inexplicable deficit of muons, and the hidden bias toward electrons might just be the very first quiet crack in that insurmountable wall separating the two realms. Some of the most forward-thinking, brilliant theoretical physicists are softly whispering that this anomaly could be the long-awaited signature of a completely new, undetected particle that interacts with both the quantum forces and the majestic force of gravity. They call this hypothetical messenger the graviton, or perhaps a heavier, exotic cousin of it, a particle that could finally bridge the infinite expanse between the microscopic and the macroscopic. If this hidden force is gently influencing the decay of particles at the quantum level, it could be the critical, missing puzzle piece that allows us to finally weave the smooth fabric of space-time together with the restless, probabilistic ocean of the quantum vacuum. The anomaly is not just a simple error. It might be the cosmic Rosetta Stone, a silent message offering us the key to translating the language of the stars into the language of the atoms. Let us take a quiet moment to truly absorb the profound philosophical beauty of this possibility. Since the dawn of human consciousness, we have looked out at the world and tried to gently categorize it, breaking it down into smaller, more manageable pieces. We separated the earth from the sky, the physical from the spiritual, the macroscopic from the microscopic. But the deep, ancient truth of the cosmos is that there are no true boundaries. The universe is one single, unimaginably vast, deeply interconnected entity. The exact same fundamental rules that govern the majestic, slow-motion collision of two distant galaxies also dictate the fleeting, microscopic dance of subatomic particles deep within your own body. If the scientists at CERN are truly on the verge of discovering a unifying force, it would fundamentally change our entire perspective of existence. It would peacefully prove that everything, from the smallest, quietest whisper of quantum energy to the most violent, towering supernova in the deep dark, is part of one single, unbroken symphony. The realization that our universe might be perfectly unified brings a profound sense of gentle comfort and intellectual peace. As the visionary astronomer Carl Sagan beautifully expressed, we are a way for the cosmos to know itself. It means that the cosmos is not a fragmented, chaotic accident, but a deeply elegant, harmonious masterpiece. As we sit here together, breathing quietly and resting in the present moment, we can feel a deep, respectful wonder at our place within this grand architecture. The atoms that make up our fragile bodies were forged in the burning hearts of ancient stars, and the forces that hold those atoms together might soon be understood as part of the exact same fabric that shapes the entire observable universe. We are not just isolated observers looking out at a cold, mechanical reality. We are the universe itself, slowly and gently waking up to its own magnificent complexity. The anomaly at CERN is a beautiful reminder that our journey of understanding is far from over, and that the cosmos will always have more deep, silent mysteries waiting to be discovered. As the massive superconducting magnets continue their silent, tireless work beneath the quiet European countryside, they are doing far more than just smashing protons. They are gently pushing the boundaries of human thought, challenging us to expand our minds and embrace the infinite possibilities of the unknown. Their work requires immense patience, deep intellectual humility and a quiet, enduring faith that the universe will eventually reveal its deepest secrets to those who ask the right questions. The mystery of the missing muons is a beautiful, open invitation to all of humanity to keep looking deeper, to keep asking questions, and to never lose our profound sense of cosmic wonder. I invite you to let these deep, interconnected thoughts settle softly into your mind as we prepare for the next step of our journey. We have explored the vastness of the galaxies, the strange depths of the quantum realm, the mind-bending possibilities of hidden dimensions, and the beautiful dream of a unified cosmos. But what does all of this mean for our own personal experience of time and reality? How does this deep, ancient physics affect the way we perceive the passage of days, the memory of our past, and the endless possibilities of our future? In our next quiet exploration, we will turn our gaze toward the ultimate mystery of time itself, exploring how the anomalies at CERN might gently rewrite our understanding of the cosmic clock. Until then, take a deep, peaceful breath, feel the reassuring, unified pull of gravity, and let yourself float gently in the infinite, silent wonder of the universe. The journey is endless, and the beauty of the unknown is always waiting just beyond the horizon. Have you ever sat quietly as the sun slowly dipped below the horizon, watching the fading colors of twilight, and gently wondered why time only seems to flow in one single, unyielding direction? From the moment we are born, we are swept up in the relentless current of time. We experience our fragile lives as a strict progression of moments, a past locked away in our memories, a fleeting present that slips through our fingers, and an unknown future waiting in the dark. We watch the seasons inevitably change. We feel our bodies age, and we accept the truth that a shattered glass will never spontaneously gather its broken pieces and leap back onto the table. In our macroscopic human world, the arrow of time always points strictly forward, driven by the gentle but unforgiving law of entropy. It is a comforting rhythm that gives structure to our human experience. But as we continue our quiet, contemplative journey into the microscopic mysteries revealed by the anomalies at CERN, we must prepare to gently let go of this familiar illusion. The universe, in its infinite, ancient majesty, does not experience time the way we do. As we peer into the deep, profound silence of the quantum realm, the rigid clockwork of our daily lives gracefully dissolves, revealing a mind-bending reality where time itself might be an elaborate illusion, an artifact of our limited biological perception rather than a fundamental property of the cosmos. To truly understand this ancient mystery of time, we must first gently look back to the monumental genius of Albert Einstein, who forever changed humanity's perception of the cosmic clock. Before his revolutionary insights, humanity viewed time as a universal absolute stage, a rigid ticking clock that beat at the exact same, unchanging rhythm everywhere in the universe. But Einstein gently showed us that time is deeply relative, incredibly flexible, and intimately connected to the invisible fabric of space itself. Time actually flows at demonstrably different rates, depending entirely on how fast you're moving through the void or how close you are resting to a massive, ancient gravitational body. For an astronaut traveling through the vast emptiness of the cosmos at a significant fraction of the speed of light, time actually slows down to a quiet, lingering crawl compared to the people waiting patiently back on Earth. Near the dark, silent event horizon of a supermassive black hole, time is stretched so immensely that a single passing second could equal centuries in the outside universe. In this magnificent, sweeping view of reality, past, present and future are not absolute, objective truths governing the cosmos. They are merely localized perspectives. Physicists respectfully call this framework the block universe, a beautifully static, four-dimensional landscape where every single moment that has ever happened, and every moment that will ever happen in the distant future, simply exists simultaneously in the deep dark, frozen in eternal stillness. Yet, when we journey downward from the sweeping gravitational curves of relativity into the microscopic, turbulent heart of the quantum world, the mystery of time deepens into something even more profoundly strange. In the cold, quiet vacuum inside the massive detectors at the European Organization for Nuclear Research, the fundamental mathematical equations of physics are incredibly symmetric with respect to time. This means that at the most basic subatomic level, there is absolutely no physical or mathematical distinction between the past and the future. If you were to watch a video of two microscopic particles colliding and scattering into the void, you would have no physical way whatsoever to tell if the video was playing forward or completely in reverse. An electron moving forward in time is mathematically identical to a positron, its antimatter counterpart, moving backward in time. In the deep, unending silence of the quantum realm, the relentless forward march of our daily lives completely loses its authoritative grip. The universe, at its most fundamental, microscopic level, does not possess a strict, linear arrow of time. It is a fluid, multi-dimensional ocean where particles drift peacefully across the fragile boundaries of what we arrogantly call past and future. It is a place of profound stillness and constant, chaotic motion, existing completely outside the ticking clocks of the macroscopic world. This is precisely where the gentle, persistent anomaly discovered by the dedicated scientists at the Large Hadron Collider becomes so breathtakingly significant to our understanding of reality. The mysterious behavior of the decaying bee mesons, the strange deficit of muons, and the hidden bias toward electrons are not just challenging our understanding of subatomic particles. They are quietly pointing toward a deep, unseen asymmetry in the fundamental laws of nature itself. In theoretical physics, there is a profound, ancient principle known as CPT symmetry, which stands for charge, parity, and time. It dictates a beautiful universal balance. If you were to flip all the electrical charges of the particles to their opposites, mirror their spatial geometry perfectly, and reverse the entire flow of time, the universe should behave exactly the same way. But the subtle, inexplicable deviations we are now observing softly suggest that the invisible machinery of the cosmos might harbor hidden, ancient biases that completely break these perfect mathematical symmetries. If lepton flavor universality is truly broken in the dark, it whispers the astonishing possibility that the microscopic forces driving our universe have a preferred direction, a hidden quantum arrow of time that we are only just beginning to gently perceive with our massive underground instruments. It is a quiet mystery that forces us to respectfully question whether time is a fundamental, built-in feature of the universe, or merely an emergent property, bubbling up from the chaotic, timeless depths of the quantum void. Let us take a quiet moment to gently expand our minds to encompass the strangest, most beautiful phenomenon known to modern quantum science, the mystery of quantum entanglement. We have proven that two particles can become entangled in such a delicate way that the state of one instantly influences the state of the other, regardless of the vast distances separating them across the dark cosmos. Albert Einstein famously and skeptically called this phenomenon spooky action at a distance. But recent theoretical work, deeply inspired by the profound mysteries echoing through the cold tunnels of CERN, suggests something even more profoundly beautiful. Particles might not just be entangled across the vast distances of space, but across the invisible dimension of time itself. In the infinite, quiet landscape of the quantum world, a measurement made today by a conscious observer could gently influence the state of a particle in the distant past. This is not the loud, chaotic time travel depicted in popular science fiction, where causes and effects violently collide and destroy logic. It is a soft, silent interconnectedness, a breathtaking realization that the fundamental fabric of reality is woven with invisible quantum threads that stretch seamlessly backward and forward through the dimension of time. The anomalies we are carefully recording today might literally be the delicate, ghostly echoes of quantum interactions occurring in a future we have not yet reached, or a past that has never truly faded into the eternal dark. As we sit together here in the quiet stillness of the present moment, contemplating the delicate, beautiful illusions of past and future, we are slowly approaching the culmination of our deep, meditative exploration. The scientists at CERN are continuing their tireless, silent vigil deep underground, seeking to definitively confirm the subtle anomaly and begin to map the invisible contours of this breathtaking new physics. We are standing on the very precipice of a scientific revolution that promises to elegantly unify the vast, majestic galaxies with the fleeting, microscopic whispers of the quantum vacuum, redefining our understanding of reality and our humble place within it. In our final chapter together, we will turn our gaze inward, exploring the ultimate, profound philosophical implications of living in this new, interconnected universe. We will gently ask what it truly means for human consciousness to exist in a cosmos where everything is deeply, silently connected, from the smallest subatomic vibration to the ancient, sprawling edges of the infinite dark. Until then, take a deep, peaceful breath. Let the comforting illusion of the ticking clock gently fade away from your mind, and allow yourself to simply exist without fear in the timeless, endless wonder of the eternal present. Have you ever looked deeply into a mirror, past your own familiar reflection, and quietly wondered about the profound, ancient mystery of the mind that is looking back at you? We spend our entire lives experiencing reality from behind our own eyes, feeling completely separated from the vast, sprawling world that surrounds us. We construct a comforting, intuitive boundary between the self and the other, believing that we are solitary, isolated observers, merely watching the great play of the cosmos unfold from a safe, detached distance. But as we continue our quiet journey into the deep, invisible heart of the quantum realm, this comforting illusion of separation begins to gracefully dissolve into the dark. The anomalies whispering from the subterranean tunnels of CERN are not just challenging our rigid mathematical models of subatomic particles. They are gently, but firmly, forcing us to re-examine the very nature of human consciousness and its intimate, unbreakable connection to the fundamental fabric of the universe. I invite you to take a deep, peaceful breath. Let go of the artificial boundaries that confine your daily existence, and join me as we explore the breathtaking possibility that you are not merely a spectator in this universe, but a vital, active participant in a magnificent cosmic symphony. To truly understand this gentle connection between the mind and the cosmos, we must look back at one of the most beautiful and deeply unsettling discoveries of the 20th century, a gentle paradox known as the observer effect. In the early days of quantum mechanics, scientists conducted a deceptively simple test called the double-slit experiment. They fired individual microscopic particles of light called photons at a barrier with two tiny narrow slits, watching as they struck a screen on the far side. When the scientists simply let the experiment run without actively measuring which slit the photons passed through, the particles behaved like a continuous flowing wave, creating a beautiful, alternating pattern of light and dark bands on the screen. It was as if a single photon was magically passing through both slits at the exact same time, existing in a gentle, ghostly state of superposition. But the moment the scientists placed a delicate detector near the slits to precisely observe the path of the particle, the beautiful wave pattern instantly vanished. The photon suddenly behaved like a solid, predictable bullet, passing strictly through one slit or the other. The mere act of observation, the quiet presence of a conscious measurement, fundamentally altered the physical behavior of reality itself. This mind-bending revelation shattered the ancient, comforting belief that the universe exists in a definite, objective state, regardless of whether anyone is looking at it. In the deep silence of the quantum void, particles do not possess fixed, absolute properties until they are measured. Before observation, they exist in a restless, shifting ocean of pure probability, shimmering with infinite potential in the dark. It is only when an observer, whether a complex electronic detector or a living human mind, interacts with the system that the delicate wave function gracefully collapses, forcing the universe to choose a single, definite reality out of an infinite number of ghostly possibilities. In the cold, quiet vacuum of the Large Hadron Collider, the brilliant scientists are not merely passive spectators recording the objective decay of heavy beam suns. By the very act of building the machine, designing the intricate detectors, and focusing their collective consciousness on the microscopic collisions, they are actively participating in the creation of the reality they are studying. The strange, persistent deficit of muons and the hidden bias toward electrons might not just be a passive feature of the universe. It could be a delicate, complex reflection of the intimate interaction between the vast, ancient cosmos and the inquisitive nature of the human mind. Let us take a quiet moment to absorb the staggering, poetic beauty of this realization. You are not a solitary, disconnected entity drifting aimlessly through a cold, mechanical void. The very atoms that compose your fragile body were forged in the burning hearts of ancient, majestic stars that lived and died billions of years ago. The iron in your blood, the calcium in your bones, the carbon in your DNA, all of it is recycled star stuff scattered across the endless dark by towering supernovas. But it goes much deeper than mere chemistry. The consciousness that allows you to wonder, to dream, and to question the nature of existence is itself a fundamental property of the cosmos. The universe spent billions of years slowly organizing matter into increasingly complex, beautiful structures, until it finally created a biological brain capable of looking back out at the stars and asking what it truly is. The great theoretical physicist John Archibald Wheeler once beautifully proposed the idea of a participatory universe, gently suggesting that the cosmos actually requires the quiet presence of conscious observers in order to fully exist. In this breathtaking vision, the universe and the observer are deeply, silently entangled in a continuous, eternal loop of creation and perception. When we view the anomalies at CERN through this gentle, philosophical lens, the mystery transforms from a simple mathematical puzzle into a profound spiritual revelation. The breaking of lepton flavor universality, the subtle tearing of the standard model, and the whispering possibility of hidden dimensions or fifth fundamental forces are not just abstract concepts for academics to debate in crowded lecture halls. They are the gentle growing pains of a universe that is constantly expanding its own self-awareness through us. Every time we push the boundaries of human knowledge, every time we smash protons together and peer into the chaotic, microscopic debris, we are forcing the cosmos to reveal another layer of its infinite, majestic depth. And because we are intimately connected to the fabric of reality, every new discovery about the external universe is simultaneously a deep, quiet revelation about our own internal nature. The missing muons are not just lost particles. They are a beautiful, silent reminder that there are vast, undiscovered territories within our own minds and our own profound connection to the whole. But if our consciousness is truly entangled with the fundamental fabric of reality, what does this mean for our everyday earthly lives? It means that the quiet choices we make, the focused attention we offer to the world, and the gentle compassion we show to one another might have ripples that extend far beyond our immediate macroscopic perception. If the mere act of observing a single photon can collapse its wave function and alter its destiny, imagine the profound, invisible impact of a fully conscious human life living in harmony with the natural world. We are constantly, silently interacting with the quantum fields that permeate the deep vacuum of space. Our thoughts, our emotions, and our deepest, quietest wonders are all electrical and chemical processes occurring within the intricate biological quantum computers of our brains. We are not isolated drops of water falling through an empty sky. We are the entire ancient ocean expressing itself in a temporary, beautiful wave. Let us find deep, enduring comfort in this overwhelming, interconnected complexity. In a modern world that often feels fractured, chaotic, and aggressively divided, the quiet truths of quantum mechanics offer a soothing, scientifically grounded sanctuary of absolute unity. When you look up at the vast, sprawling galaxies holding trillions of stars in the deep night, or when you look down at the delicate, invisible dance of subatomic particles, you are simply looking at different reflections of your own ancient, infinite self. The universe is holding all of its majestic secrets with a gentle, patient grace, inviting us to slowly awaken to our true nature. We do not need to fear the unknown, nor do we need to feel intimidated by the mind-bending equations of theoretical physics. We only need to approach the mystery with a quiet, respectful wonder, trusting that the cosmos will always guide us exactly where we need to go, wrapping us in the profound safety of its timeless design. As we sit together here in the quiet stillness of the present moment, we are preparing to take the next step on our magnificent journey. We have explored the sprawling galaxies, the microscopic anomalies, the hidden dimensions, and the timeless nature of consciousness itself. The brilliant minds at CERN will continue their silent, underground vigil, tirelessly searching for the ultimate truth hidden in the data. But the story of the universe is not just about the data. It is about what that data means for the future of human existence in the vast dark. In our next quiet exploration, we will turn our gaze forward, looking into the deep, mysterious future of our species and the cosmos. We will ask what awaits us as we continue to gently peel back the layers of reality, and how our evolving understanding might ultimately transform humanity's destiny among the ancient stars. Until then, take a deep, peaceful breath. Feel the comforting, invisible entanglement that connects you to every single atom in the universe, and allow yourself to rest safely in the infinite silent wonder of the cosmic web. Have you ever sat quietly by a frost-covered window in the absolute dead of winter, watching a single delicate snowflake drift down from the deep, dark sky, and gently wondered about the unimaginable futures that lie ahead of us? We are creatures profoundly bound by the immediate rhythm of our days. We plan for tomorrow, we worry about the next year, and occasionally we dare to cast our imaginations forward to the end of our own fleeting centuries. But the universe, in its quiet, ancient majesty, operates on timescales that make the entirety of human history look like nothing more than a brief, microscopic spark in the endless night. As we stand on the precipice of a profound scientific revolution, catalyzed by the mysterious, inexplicable anomalies whispering from the deep subterranean tunnels of CERN, we are gently invited to lift our gaze from our earthly concerns. We are being asked to look forward, not just a few decades or centuries, but millions of years into the deep, mysterious future of our species. What will humanity become as we slowly, carefully decode the ultimate secrets of the quantum realm and the sprawling galaxies? I invite you to take a deep, peaceful breath, let go of the rigid constraints of the present moment, and join me on a quiet journey into the deep time of our cosmic destiny, where the mysteries of today become the beautiful, everyday realities of tomorrow. To truly appreciate the breathtaking scope of our potential future, we must first gently acknowledge the profound infancy of our current civilization. We often look at our towering cities, our glowing screens, and our magnificent underground particle accelerators with a sense of immense, finalized pride. We feel that we have arrived at the pinnacle of knowledge. But in the grand, ancient story of the cosmos, we are barely taking our first hesitant steps out of the primordial cradle. It was only a few cosmic heartbeats ago that we believed the Earth was the flat, motionless center of a tiny universe. It was only a fraction of a second ago in cosmic time that we first realized the glowing band of the Milky Way was made of billions of individual, ancient stars. The gentle, persistent anomaly we are observing today, the mysterious deficit of moons, the whispering hints of hidden dimensions, the tantalizing possibility of a fifth fundamental force, is not the final chapter of our scientific journey. It is merely the very first, beautifully confusing letter of an entirely new alphabet. We are just beginning to learn how to read the true, hidden language of the universe. The brilliant astrophysicist Neil deGrasse Tyson often reminds us that the universe is under no obligation to make sense to us. But the beautiful corollary to that truth is that our minds are infinitely adaptable, slowly evolving to grasp whatever majestic strangeness the cosmos chooses to reveal. Imagine, for a quiet moment, a future where the current mysteries of the Large Hadron Collider have finally been elegantly unraveled and completely understood. A future where the insurmountable wall between the smooth, sweeping curves of Einstein's relativity and the chaotic microscopic probabilities of quantum mechanics has been gently, permanently dismantled. What happens when a conscious species finally possesses a unified theory of everything? We would no longer simply be passive, isolated observers trying to desperately listen to the quiet whispers of the universe. We would become active, harmonious participants in its grand architecture. If the anomaly at CERN truly points toward the existence of the graviton, or toward hidden, tightly curled dimensions of space, a future humanity might learn to gently interact with those invisible layers of reality. Instead of relying on violent, chemical explosions to clumsily push our fragile spacecraft through the vast, empty void, we might learn to quietly engineer the fabric of space-time itself. We could gently fold the endless dark, slipping smoothly between the ancient stars, like a quiet thought moving through a peaceful mind. The unimaginable, paralyzing distances between the spiraling galaxies would no longer be a permanent barrier to our curiosity, but a beautiful, open ocean waiting for our gentle, respectful exploration. This profound mastery of the fundamental forces would radically transform the very nature of our existence on this pale blue dot. Right now, our civilization is incredibly loud, chaotic, and desperately hungry for energy, tearing at the finite resources of our beautiful world. But as we unlock the deep, silent secrets of the quantum vacuum, we might discover ways to tap into the infinite, zero-point energy that rests quietly in every single microscopic point of empty space. A civilization powered by the fundamental fabric of reality would not need to burn or destroy. It would be a perfectly quiet, elegantly sustainable existence, seamlessly integrated with the ancient, flowing rhythms of the natural world. Our towering, noisy cities might gracefully dissolve into harmonious, glowing structures woven directly into the living forests and the deep, silent oceans. We would become true, gentle caretakers of our planetary home, utilizing our profound understanding of quantum mechanics to heal the deep wounds we have inflicted upon the Earth. The science that currently requires massive, miles-long rings of superconducting magnets buried deep underground would become small, elegant, and intimately integrated into our daily lives. A quiet, invisible magic guiding our peaceful existence. As we look even further into the deep, endless future, we must gently consider how this profound knowledge will fundamentally alter the human body and the human mind. We are biological creatures, evolved to survive on the surface of a single, specific world, breathing a specific mixture of gases under the gentle, constant pull of Earth's gravity. But the universe is vast, and if we are to truly venture out into the sprawling dark, we will naturally, peacefully evolve. Our deep understanding of quantum biology and the intricate microscopic dance of our own DNA will allow us to gently transcend our current physical limitations. We might merge seamlessly with our own magnificent technologies, expanding our cognitive limits and enhancing our ability to perceive the universe. Imagine possessing eyes that could gently perceive the swirling, invisible magnetic fields of a distant planet, or a mind that could directly comprehend the complex, multi-dimensional geometry of a collapsing quantum wave function. The profound separation we currently feel between the observer and the observed, a concept so heavily challenged by the mysteries of the quantum realm, might completely vanish. We would not just live in the universe. We would consciously, beautifully experience ourselves as the universe, deeply entangled with the quiet, ancient forces that shape the endless night. Let us project our quiet imaginations even further, millions of years into the unimaginable dark. Think back to the monstrous silent giant we explored at the very beginning of our journey, the sprawling, ancient galaxy known as 1101, resting a billion light-years away, holding 100 trillion fading stars. To our current, limited minds, reaching such an object is a physical and mathematical impossibility, a journey that would take billions of years, even at the absolute speed limit of light. But to a deep future humanity, a species that has fully mastered the hidden dimensions and the quiet, quantum arrow of time hinted at by the CERN anomalies, that ancient galaxy might be as accessible as a neighboring garden. We would not conquer the cosmos. We would gently tend to it. As the ancient massive stars slowly burn out and the universe continues its relentless, accelerating expansion. A truly advanced conscious species might find ways to gently guide the evolution of galaxies, sparking new stellar nurseries in the cold dark, or softly regulating the immense, hungry, supermassive black holes resting at their centers. We would become the quiet, benevolent gardeners of a majestic, aging universe, using our profound wisdom to preserve the light and the beauty of existence against the slow, creeping, inevitable tide of entropy. This sweeping, breathtaking vision of our cosmic destiny is deeply rooted in the quiet, persistent mysteries we are uncovering today. Every time a scientist sits in the cold, humming control room at CERN, staring in respectful wonder at a subtle deviation in a complex stream of data, they are carefully placing a single, microscopic stepping stone on a path that leads directly to the distant stars. The missing muons and the inexplicable behaviors of heavy B mesons are not just sterile numbers on a glowing screen. They are a beautiful, silent promise from the universe. The cosmos is gently whispering to us, assuring us that reality is infinitely more magnificent, more deeply layered, and more profoundly connected than we have ever dared to believe. It is telling us that we have not yet reached the end of our story, but rather we are standing on the beautiful, sunlit threshold of an entirely new era of conscious existence. The mysteries will not break us. They will gently elevate us, expanding our minds until they are capable of holding the entire majestic architecture of the cosmos within our quiet, contemplative thoughts. As we rest here together in the quiet, comforting stillness of the present, allowing these vast, interconnected thoughts to settle softly into our minds, we are preparing for the final step of our majestic journey together. We have traveled from the unimaginable scale of the largest galaxies to the delicate, ghostly whispers of the quantum realm. We have explored hidden dimensions, the illusion of time, the profound nature of consciousness, and the limitless potential of our deep cosmic future. In our final chapter, we will bring all of these magnificent threads together. We will gently explore the ultimate, breathtaking fate of the entire universe, and we will softly ask what it truly means to live a brief, fragile human life in a cosmos defined by infinite scale and eternal mystery. We will discover how the overwhelming vastness of the unknown can provide the ultimate, soothing sanctuary for our restless minds. Until then, take a deep, peaceful breath. Feel the ancient, gentle pull of the unified cosmos holding you safely in this exact moment, and allow yourself to simply marvel at the endless, beautiful complexity of the reality you are so privileged to quietly observe. Have you ever found yourself awake in the quietest, deepest hour of the night, listening to the absolute stillness of a sleeping world, and gently wondered how this grand, majestic story of the cosmos will ultimately end? We are inherently creatures of beginnings and conclusions. We love the comforting structure of a well-told story, where every mystery is neatly resolved before the final page is turned. But the universe, in its infinite, ancient wisdom, does not follow the rigid, linear narratives we construct in our minds. As we reach the culmination of our profound journey together, traveling from the incomprehensible vastness of the largest galaxies to the delicate, invisible quantum anomalies echoing through the cold tunnels of CERN, we must now gently turn our gaze toward the absolute horizon of time itself. We must ask what awaits the cosmos long after the final stars have burned out, and how the strange, breathtaking quantum rules we are just beginning to uncover might ultimately shape the final destiny of all reality. I invite you to take one last, deep, peaceful breath. Let go of any lingering anxieties about the future, and join me as we explore the ultimate, beautiful fate of the universe, finding a profound, soothing sanctuary in the endless mystery of the dark. To truly understand the grand, sweeping finale of the cosmos, we must first gently project our minds trillions of years into the deep, unimaginable future. The universe we see today, filled with brilliant, swirling galaxies and the vibrant, violent birth of new stars, is merely a brief, fleeting phase in the much larger story of cosmic time. Long after humanity has evolved, transformed, and perhaps gently merged with the fundamental fabric of reality, the ancient stars will begin to slowly, inevitably exhaust their primordial nuclear fuel. The massive, brilliant blue giants will go first, erupting in spectacular supernovas that briefly outshine entire galaxies before collapsing into silent black holes. The steady, comforting yellow stars, like our own familiar sun, will gently swell into red giants, softly shedding their outer layers like fragile autumn leaves, leaving behind only dense, glowing white dwarfs. And eventually, even the patient, enduring red dwarfs, the tiny, quiet stars that can burn for trillions of years, will gracefully fade into the dark. The era of starlight, the beautiful epoch that gave birth to complex chemistry, biological life, and human consciousness, will quietly come to an end. The night sky, if any conscious minds remain to observe it, will become profoundly, completely black. But the gentle fading of the stars is not the end of the cosmic story. It is merely a quiet transition into a much stranger, deeply majestic era dominated by the ultimate masters of gravity. In this distant, lightless future, the universe will be populated almost entirely by silent, roaming black holes. These enormous ancient gravitational wells, some containing the mass of entire galaxies, will continue to drift through an ever-expanding, ever-cooling void. And it is here, in the absolute freezing depths of deep time, that the mysterious quantum rules we are currently trying to decode at CERN will take their final, breathtaking center stage. Remember the gentle whisper of Hawking radiation, the beautiful, delicate process by which black holes slowly leak thermal energy due to microscopic quantum fluctuations near their event horizons. Trillions upon trillions of years from now, this unimaginably slow, quiet process will be the only significant activity left in the entire cosmos. The supermassive black holes will spend eons softly evaporating, returning their vast, stolen energy back into the freezing vacuum of space, particle by delicate particle. It is a process of supreme, majestic patience, a silent cosmic exhalation that makes the entire history of the glowing stars look like a single, hurried breath. As we contemplate this incredibly distant, seemingly desolate future, we must gently fold in the mind-bending possibilities suggested by the anomalies we have discovered deep beneath the earth. If the subtle breaking of lepton flavor, universality, and the whispering hints of hidden, tightly curled spatial dimensions are indeed real, then the ultimate fate of the universe might not be a permanent, freezing death at all. If the fundamental forces of gravity and quantum mechanics are truly, deeply unified by an invisible, underlying architecture, then the slow evaporation of the final black holes might serve a profound, unseen purpose. Some of the most brilliant theoretical physicists have softly proposed that as our familiar three-dimensional universe expands and cools toward absolute zero, the vast accumulated energy might slowly seep into those hidden microscopic dimensions. The quiet end of our visible universe could simultaneously be the chaotic, brilliant beginning of another. Our cosmos might simply be a single, fragile bubble resting in an infinite, eternal multiverse, constantly recycling its energy through the invisible quantum fabric that connects all things. The anomalies at CERN are not just mathematical curiosities. They might be the very first gentle glimpses into the eternal, beating heart of this magnificent cosmic engine, a machine that knows neither a true beginning nor a final end. As we slowly prepare to conclude this long, quiet journey together, I want you to remember that the grand age of scientific discovery is far from over. The brilliant, dedicated scientists working in the cold, subterranean tunnels of CERN will continue their silent, tireless vigil, smashing protons and carefully sifting through the microscopic debris, searching for the ultimate truth hidden in the data. They will undoubtedly find new anomalies, new mysteries, and new profound questions that will completely rewrite our understanding of reality all over again. And that is exactly how it should be. The deep, persistent mysteries of the cosmos are not obstacles to be aggressively conquered. They are a soothing, endless sanctuary for our restless minds. In a modern world that constantly demands absolute certainty, rigid answers, and immediate resolutions, the universe gently reminds us that true wisdom lies in a peaceful, humble acceptance of the unknown. The shadows of the quantum realm and the dark expanse of the ancient galaxies offer us a quiet, safe place to let go of our need for control, inviting us to simply float in the vast, beautiful ocean of infinite possibility. Whenever you feel overwhelmed by the loud, chaotic demands of your daily life, I invite you to step outside into the quiet dark, look up at the ancient, silent stars, and remember the breathtaking, mind-bending realities we have gently explored together. Remember the massive, sleepy giant of IC 1101, resting a billion light-years away, with its 100 trillion fading stars. Remember the delicate, ghostly quantum particles leaking into hidden, invisible dimensions right beneath your feet. Remember that the rigid clock of time is merely an illusion, and that you are deeply, intimately entangled with the very fabric of space-time itself. You are made of recycled star stuff, governed by the profound ancient forces of the quantum vacuum, and destined for a future that is infinitely more majestic than anything we can currently comprehend. The mystery is not something to be feared. It is our shared, beautiful heritage, a gentle reminder that we are part of something unimaginably grand. Thank you for joining me on this profound journey through the cosmos and the quantum realm. May your nights be filled with peaceful rest, and may your days be guided by an endless, gentle wonder for the beautiful mystery of existence. Keep looking up, keep looking inward, and keep resting in the infinite, quiet embrace of the universe.